First question. Show that the roots of the equation 1 minus k x squared plus x plus k equals 0 are real and negative in that given range. So if we want to show roots of this quadratic equation are real, we have to consider the discriminant. Discriminant of the quadratic equation delta is b square minus 4ac. b is the coefficient of x term, which is 1 here, so square of that, minus 4 into a. a is the coefficient of x square term into c. c is k. So when we simplify, we get minus 4k plus 4k square. So this is the perfect square of 1 minus 2k square. Perfect square of 1 minus 2k. Square of 1 is 1. Square of 2k is 4k square. Middle term is 2 into first term into second term. That is minus 4k. So a perfect square is always greater than or equal 0. And delta is greater than or equal 0. Therefore, roots are real. Now we have to show within that given range, roots are negative. So let's consider the roots of this quadratic equation be alpha and beta. Then take the product of roots. Alpha into beta is c over a. c in this particular equation is k. a is 1 minus k. So alpha beta product is this. If roots are negative, both roots are negative. If roots are negative, alpha into beta product should be greater than 0. It should be positive because both are negative. Minus into minus is plus. So k divided by 1 minus k should be greater than 0. Then we can simplify this inequality. There are two roots for k. One is 0, the other one is 1. Now consider a value in this range minus 2. Substitute minus 2 for that fraction. Minus 2 divided by 1 minus minus 2. So numerator is negative, denominator is positive. Final answer is negative. So within this range, the answers are negative. Then in inequalities, we know the other range should be positive. This should be negative. Minus plus minus pattern goes on. Here they are saying this should be greater than 0. That means positive. So we have to consider this positive range. So it lies between 0 and 1. Therefore, roots are negative. Roots are negative within 0 and 1. That means k should be greater than 0, less than 1. Second question. Find all real values of x satisfying the inequality 3 minus modulus x plus 1 greater than, less than x square. So first we have to consider the left hand side equation. This one. So y1 is, consider the modulus, the expression inside the modulus bracket, and equate that to 0. Then we can see the values of the modulus bracket changes either side of x equal minus 1. So when x equal minus 1, we can have an exact value for the function. So substitute x equal minus 1. So when this is minus 1, minus 1 plus 1 becomes 0. Then the answer is 3. 3 minus 0 is 3. So value of the function when x equal minus 1 is 3. Then we have to consider when x equal x less than minus 1 and x greater than minus 1. When x is less than minus 1, so consider a value minus 2, then substitute minus 2 for x inside the modulus bracket. So it is clear we get a negative answer inside the modulus bracket. Then it should be 3 minus we get a negative answer inside the modulus bracket. So take that minus sign out. Minus into minus, when we multiply we get plus. Then it is 3 plus x plus 1. Now simplify this. The equation is y1 equal x plus 1. Then next one, greater than minus 1. Substitute 0, 0 plus 1. So we get a positive answer. Then we have to remove the modulus bracket and put plus in front. Then when we simplify, we have 3 minus into plus minus 6 plus 1. Final answer is minus x plus 2. Now we can draw the graph. The turning point is x equal minus 1, y equal 3. When x is less than minus 1, in this range, x equal less than minus 1, the function is x plus 1. The intercept is plus 4, gradient is plus 1. So this line passes through plus 4 and with an increase in gradient. Plus 4 and increase in gradient. This is plus 4. Then when x is less than minus 1, greater than minus 1, now we are here greater than minus 1, intercept is plus 2, gradient is negative 1. This is the line. So this is minus, this is plus 2. The function is y equal x plus 4. Here the function is y equal minus x plus 2. Now the next graph, I am considering that as y2 in blue color. It is just x square. So it is a parabola, x square symmetric around y-axis like this. So I will consider this parabola x square will intersect at here and here. So I am considering this as alpha and this place as beta. Now I have to find alpha and beta. To find alpha, I have to simultaneously solve this with this. That is those are the two equations of the lines that are intersected at alpha. So minus x plus 2 equal x square. Then we get a quadratic equation. We have to factorize that. So x equal 1 and the other one is minus 2. That means this is alpha, this is beta. So we can get both answers in one equation. Now in this inequality, they are saying the parabola is above. Parabola must lie above the modulus graph. So we can see the parabola is above the black color line when it is less than beta and greater than alpha. The blue color line is above the black color line. So the answer is x is less than minus 2 and x is greater than 1. This is the solution. Third question, they have given an equation with powers, 3 to the powers. So we have to simplify their indices first. 3 to the power 2x plus 1 can be written as 3 to the power 2x into 3 to the power 1. Here 3 to the power x into 3 to the power 4. Then bring this 3 to the power x to left hand side. Then we can have a substitution. Let y equal 3 to the power x. And this is 3 into 3 to the power x squared. 3 to the power 2x can be written as 3 to the power x squared. This is 3 to the power 4 into 3 to the power x, and we can factorize these two terms. 3 to the power 3 is 27. 3 to the power x is a common factor. Then it is 3 to the power 4 plus 1, because we have taken minus sign out. Now we can use the substitution. This is 3y square minus 3 to the power 4 is 81. 81 plus 1 is 82. 82y plus 27. Now factorize this. 27 into 1. Put both minus, because we should get minus 82 when we multiply these two and these two. We get y equal 1/3 or y equal 27. Now what is y? For our substitution, 3 to the power x. 1 over 3 can be written as 3 to the power minus 1. Therefore x is minus 1. 3 to the power x equal 27 is 3 to the power 3. Therefore we get x equal 3. Fourth question. Let there is a common linear factor for both polynomials. So I have labeled that polynomial as f of x. The other one is g of x. So there is a common linear factor for f of x and g of x. We have to show that the above common linear factor, that same factor, is there for the given polynomial. So let's consider the common factor as, let the common factor be x minus p. So we can substitute x equal p. If it is a factor, f of p and g of p must be 0, because it is a factor. F of p must be 0. Then substitute p for x, p cube plus ap square plus b equals 0. This is the first equation. Then g of p is ap cube plus bp square plus p minus a equals 0, second equation. Now we have to simplify these, simultaneously solve such that p cube terms get cancelled, because in our given the third equation doesn't have x square term. So we have to cancel out the p cube terms. For that we have to multiply the first one with a, and then subtract it with second equation. So when we multiply first equation by a, we get a p cube plus ap square a square p square plus ab minus second equation ap cube minus bp square minus p plus a. Minus into minus a become plus a. Now ap cube minus ap cube get cancelled. P square is common for these two terms. So we get a square minus b. Then take a out from these two terms. A is common plus a. Then we have b plus 1. Then minus p. Now we can substitute x equal p, because we have taken x minus p as a factor. Then the root is x equal p. Then we have a square minus b x square plus a into b plus 1 minus x. But the given expression has b minus a square as the coefficient of x square. So take all these terms to right hand side, or else we can just interchange the coefficients by taking a minus sign out. Then here also we have to take that minus sign out. Then this become plus 6. Okay, I think I have done a mistake here. Just redo the step. Multiply the entire equation by minus. Multiply the entire equation by minus. Then it is a square minus bx square minus a b plus 1 minus into minus plus 6. Now we can multiply the minus sign inside the bracket. Plus 6 minus a times b plus 1. So this is the equation, this is the polynomial they have given and asked us to show x minus p is a factor. So we have substituted x equal p. So we can say therefore x minus p is a factor of the above polynomial. Fifth question, if sec theta plus tan theta equal p, deduce that tan theta equal p square divided by p square minus 1 divided by 2p. So the value of p is given. So let's consider p square minus 1 over 2p. If we can show this is equal to tan theta, we are done. So consider this p square minus 1 over 2p sec theta plus tan theta square minus 1 divided by 2p. Take the square of this one, sec square plus tan square plus 2 sec tan minus 1 divided by 2 sec theta plus tan theta. Sec square theta can be written as 1 plus tan square theta. Now we can convert this into sine and cos. Let's do that in next step. We can cancel minus 1 and plus 1. There are two tan square terms. So 2 tan square is sine square theta over cos square theta. Plus 2 sec tan can be written as 2 sine theta over cos square theta when we convert sec tan to sine cos. Then here we get 1 over cos plus sine over cos. Then when we take the common denominator is cos. We have 1 plus sine theta. Now multiply. We can divide these two. So here 2 is a common factor. Cos square is a common factor. Then inside the bracket we have sine square theta plus sine theta divided by 2 over, let's multiply that by cos term such that we can cancel these two denominators. Since I have multiplied the denominator by cos, I have to do the same thing for the numerator. When 2 get cancelled, we can take sine term out from the numerator expression, sin theta plus 1. We can take a cos theta out from the denominator. Then we have sin theta plus 1. Sin theta plus 1, sin theta plus 1 get cancelled. Here we get tan theta. Therefore, we can say this final answer tan theta came from p square minus 1 over 2p. These two are equal.